Hello, grade 8s. Today we're going to look at how to change the scale of a graph. First, we're going to start by looking at some established graphs from our textbook. This first one, showing a vendor at a stadium, has collected data about favorite hot dog toppings, and she's used that data to create a bar graph. So we can see this is the tally sheet of information she has: ketchup, mustard, relish, and hot peppers. Then when we look at the graph, we can start to see some things that are happening. The first idea is, what does the graph appear to show about the popularities of these toppings? Well, in this graph, it shows that ketchup is by far the winner. Unfortunately, having used this graph, hot peppers completely disappeared. That's because they used an axis break. So if they have broken the graph, that's usually so that they can show you in more detail something that is happening. But it's not always accurate, nor is it always correct. So we're going to look at how could we change this so that there's less of a difference between the two graphs. First, let's look at it if it's done completely properly. We go from 0 up to 400. We've included all 4 toppings. All the scales are done accurately. When we look at this graph, ketchup is still the winner, but it doesn't look like it's beating mustard by as much. Let's look at another. Here we've got the amount of pop for each person. So the annual amount of pop that people drink. We've got the liters, and we've got the years that it was recorded in. So in 1971, people on average were drinking 54 liters of pop. By the year 2001, it had almost doubled. Now when we look at this particular graph, again, because they've put in an axis break, the data has been manipulated a bit. We know that in those 40 years, it's approximately doubled. But when we look at the graph, does the green look like it has doubled the blue? No, it shouldn't. The green is by far much larger than the blue. So if we were going to draw another graph that had smaller increases from decade to decade, we're going to show you another one. First, I'm going to turn that right side up so that for some of you it's easier to look at. In 1971, we've got a small amount, and it's slowly increasing. You'll notice that I also have a line break, or an axis break, where some of the data, some of the increments have been removed. So it looks like there's been a steep increase in the amount of pop people have drunk. Now, if we redo that graph without the axis break, how does that change? Well, now we've got going all the way from 0 up to 120. Before, we started at 60 and we went up to 120. So it's the same data without the break. When we look at it this way, we can see that yes, the pop increase has happened, and it does look to be approximately double. In this first graph, it seems to be a little bit misleading. So we're going to look at, if we're going to design a bar graph to influence a reader, we want to influence them on purpose. We have 2 different types of graphs showing exactly the same information. We're starting with ketchup, mustard, relish, hot peppers. Same information here, only the hot pepper is completely vanished off our chart. We can see that ketchup accounts for 300 in both graphs. The mustard is 275 in both graphs, and the relish is 155 in both graphs. So the information is the same. If I want it to appear that there's a huge increase or a huge contrast, I want one bar to seem like it is by far the winner. I'm going to have smaller increments along the side, and I'm going to make sure that we have an axis break between 0 and the first piece of data. If I want there to appear to be smaller or minor contrasts, I'm going to have larger increments. Instead of counting up by 50s, I'm going to go up by hundreds, and I'm going to have absolutely no increment break, so no broken axis. You're going to be working on some homework, but before you do, we're going to show you the notes again so that you can take them down in your scribblers.